We take these wood chips and during only 40 seconds it's turned into something like this.
Palm oil is the most widely used vegetable oil in the world, used to produce around half of the products in your local supermarket. And not just food, it's also an essential component of cosmetics and cleaning agents. But excessive palm oil production can be incredibly destructive. Between 2001 and 2019, it was responsible for 23% of global tropical deforestation. It also directly threatens around 193 species, including tigers and rhinos. In Southeast Asia, converting a single peat swamp forest to a palm oil plantation can contribute as many greenhouse gas emissions as half of the aviation industry in 1 year. So the hunt is on for alternatives.
Raul, hi.
Good morning, welcome to Innovator.
Thank you for having us.
So I have a couple of things for you.
Okay, we've got the high-vis vest,
Helmet.
and goggles by the looks of it
Yes,
too.
the safety goggles as well. So
Thank you
these
very
are for
much.
you.
Right,
you.
I am ready to go when you are.
Raul Rinken is the project manager at Fibenol, an Estonian company hoping to replace palm oil with products made from an industrial waste that is probably found all over the earth: sawdust. And all that sawdust can actually be used to make food.
Where does this come from?
Everything you can see here is from local forests. So we source our material from like 30 up to 60-mile radius from here, and also from certified forests.
Certified forests are where wood is sustainably harvested. These trees were chopped down for use in the plywood industry. What's left behind is usually burnt.
Huge heap of chippings that we can see here.
Yes. So you can see it's a mixture of things here. So we have these larger chips, which are actually coming from this wood here. And we also have like a very thin material, you can see. So this is actually a waste product from plywood industry. When they produce plywood, which is done fairly extensively in Estonia, you always have a residue. So we have like tens of thousands of tons of this waste material, which is usually burned. However, in our process, we can use this very thin waste material as a process input and make something useful.
More than 90% of that wood waste, or as Fibenol calls it, biomass, is converted into high-value products. There's actually a term for this: valorization. It means adding value to something that already exists. Fibenol mostly uses birchwood, but the company says its technology, which it calls Sunburst, can work with most kinds of hard wood.
So this is actually where the magic happens, or where the wood chips we saw outside are turned into a liquid wood.
Fibenol bought the core technology that's used to treat the wood from an American company before adding its own modifications. It goes through up to 40,000 tonnes of biomass a year, using heat, pressure and mechanical power to convert the wood into a slurry.
That does not look at all like I expected. What is this?
So this is actually what happens in the first step of the process. So we take these wood chips we saw outside, come in to the extruder, and during only 20 to 40 seconds, this whole wood mass is turned into something like this: a hot chocolate or chocolate mousse.
It does look like a hot chocolate, and it's hot too.
Exactly, and this is a mixture of liquid and solid particles. We call it slurry, but you can see it's pretty much liquid wood.
Like, is it edible?
I wouldn't eat it, but it's definitely not harmful. It's pretty much broken down wood, but as humans, we can't digest too well very long sugar molecules. So
Okay, I think I'll follow your lead on that one.
Here's how it works. A polymer is a substance that's made up of very large molecules, which are formed of smaller identical units called monomers. Wood is basically made up of three main polymers: cellulose, hemicellulose, and lignin, that are basically chains of sugar molecules. Cellulose, roughly half of any wooden biomass is like a long chain in the middle. The hemicellulose, about a quarter of the wood, is bound to the cellulose with lignin. In the first part of Fibenol's process, the hemicellulose is broken down into individual links or monomers, along with a little lignin. That's the liquid part of the slurry we just saw. The solid bits that are left over are the cellulose and remaining lignin. The solid and liquid are then separated from each other.
This is the same thing as before, but the solids are taken away. You can imagine it as a sweet solution which can be used as a food for bacteria and also in food industry. We also have the solid. So this material here is rich in lignin and cellulose and goes like further downstream processing to turn this mixture here into distinctive products at the next stage.
Fibenol uses enzymes to break down the solid even further. It can remove the cellulose to make a pure lignin product, or break down the lignin to make something called specialty cellulose.
The solids are actually traveling to these green large tanks where the enzymes start working, so breaking down the long chains of cellulose into small links.
As talking about the big, huge silver cylinders, we can see what's happening inside there.
So this is actually where the liquid part from the previous process step is getting turned into a thick syrup. So essentially, we evaporate out the water in these large cylinders here. This is rich in sugars or monomeric sugars and can be used as a feedstock or as a precursor in food industry.
So this product is the final one that will then be turned into something that is edible?
For the food industry, it needs a bit more refining. So we are the producers of material for other industries in that sense. So we create products which are like further processed in other areas.
One company that takes over the next stage is IO. It's a biotechnology firm based in the Estonian capital Tallinn, and it uses that sawdust-derived syrup from Fibenol to make food, among a bunch of other things. Nemaila Bonturi is IO's co-founder and CEO.
What's the problem you're seeking to fix?
Although it doesn't seem like, but food production, feed production, it also harms a lot the planet. So by using microbes, instead of animals or plants, we use way less water, way less land, way less resources. So we can replace palm oil, we can replace coconut fat and also animal fats to the moment.
I should say here, there are actually ways to sustainably produce palm oil, but it's only a tiny fraction of the overall industry. Nemaila says IO doesn't want to compete with other sustainable products out there, but provide more alternatives to the market.
We can produce these fats and oils in a way shorter time, using way less resources and with less footprint to the planet. So that's a really huge advantage. And if we have to feed billions of people, billions of animals, and well, we need a world for tomorrow, so we can achieve results faster.
They're also targeting coconut oil. It's often seen as a viable alternative to palm oil, but pesticides used on coconut plantations can contaminate the wider environment, and growing coconut trees takes huge amounts of water. Plantations can also reduce biodiversity and degrade soil, affecting its fertility.
And how wide are the range of products that yours could then go on to substitute palm oil or coconut oil or animal fats for?
Palm oil, I guess, is an ingredient of about 50% of all industrialized products in the world. So it can go from soap, from dishwashing, laundry washing, to food, feed. So basically we could substitute palm oil in all these formulations. For coconut and animal fat, the same way. In meat alternatives, dairy alternatives, for the feed, especially for fish, for cattle, for cosmetics. We technically can replace not only palm oil or coconut, but in soaps, in moisturizers, lip balms.
And all those products depend on a process that's similar to brewing beer. It's a kind of fermentation and involves a special type of yeast.
So in this busy, noisy space, it's our pilot plant. It's where we transform the material that comes from Fibenol, where they extract the sugars from sawdust. And here, it's actually where the transformation from sugars to fats and oils happens. So in the bioreactor, we're gonna produce the yeast biomass. So our first product, we call it encapsulated fat. But if you want the pure oil, we can remove the oil from inside the cell in the form of a liquid oil or a butter.
But in this space, it's the encapsulated fat that you're creating.
Yes.
And how does that work?
We call it microbial fermentation. So the yeast inside the reactor is able to eat the sugars, grow, and get very fatty and oil. And then from the bioreactor, we harvest those cells and then we dry them.
The process is fairly common, but the end result is what's unique. Is that right?
Yes, exactly. So the yeast, the strain we are using, it was evolved by us to be more tolerant to industrial environments and also to all this type of harsh materials to grow. So it's very robust and efficient to turn sugars into fats and oils and other compounds as well.
The yeast Namila mentioned is what IO's core technology hinges on. Namila developed this particular strain herself during her PhD back in Brazil. Along with her team, she's even sequenced its entire genome, so she'll know if someone's using it without her authorization.
So before adding our yeast to the big bioreactor, we need to grow them in a smaller volume that we call inoculum. So here is where we're preparing the inoculum for the bioreactor. Here we have our yeast and the material from Fibenol. So this is where the process is started, and then we transfer it to the bioreactor using a pump later.
And what's actually happening? What's the process that we can see bubbling away?
So this yeast, it needs air, sugar, it needs the perfect environment to grow and be ready for production.
The yeast, which IO calls the red bug, is then fed on those sugars that originally came from sawdust. And then the yeast becomes fat, much like humans if we gorge on food.
So inside here, we go from that 10-15 liter scale to a 300-400 liter scale.
We can see in the window.
Yes, yes.
Oh, you can see it all wearing around.
Yes, they're happily growing and getting very, very fat.
And so the liquid will be in here for a week?
Actually, less than a week, so it will stay here for about 3 days.
What do all these machines do?
The red machine is compressed air. Then we have an air tank, the green one, where it stores the air. The blue small equipment is to dry the air. And this is for cooling down the temperature in the reactor. And to sterilize and to also heat up the reactor, we have a steam generator machine just there.
So there's a huge amount that goes into ensuring the perfect conditions inside here.
Yes, exactly. We pamper our yeasts. That's why they produce very nice products.
So nicely pampered yeast.
Yes.
Once IO's fed the yeast with enough sugars derived from sawdust, it extracts fats and oils from it. Exactly how that extraction takes place is a business secret. But it lets them produce something that can replace a pretty key ingredient in food. This is where Evelyn Numi comes in.
What are you making today?
I'm making muffins. Everybody knows how to make muffins, so I don't need to teach, but I'm just going to explain you.
Okay, so the basis of this is exactly as you
Exactly
would make
like
normal muffins.
regular muffins.
Okay.
So normally butter goes in to make it softer, but that's where we are using our IO biomass, so replacing the butter.
Does it change how you're making your muffins?
Not really, but you have to know how to, like, where to use it and how to use it. And I have a great chef also who's working with me. He's really testing like how it should be used, like for restaurants or for other clients. So now I'm gonna use our yeast, the biomass.
Can I taste it?
Yes, sure. We're tasting it here all the time, so otherwise we can't prove the message. So
Yeah,
I'll give you a little bit because it's very powderish.
It does look just like a flower, a pink flower, doesn't it? Oh wow, that texture is not like flour at all.
But it looks like.
It looks just like flour, but it's kind of thick.
It's a rich oil and proteins.
That is a really unusual flavour and texture, not at all what I expected.
Rich in proteins, but not so much in flavour. It also smells a lot like the sawdust we saw earlier, but I'm hoping it won't affect how the muffins taste.
What I'm gonna do is put the powder in.
So you're adding it as you would add flour, sieving it into the mixture.
See, this is a wonderful color.
Is the colour natural?
Everything is natural.
It almost looks like kind of cosmetics, like a blusher.
Yes. It looks like artificial.
Yeah.
Because it's like, can't be real, but it is.
And so then you just whisk this as you would a normal muffin recipe?
Yes, so I'm gonna just mix it in.
That colour is really something.
Yeah, so that means you don't need artificial coloring, for instance. If you want pink, brownish muffins, candies.
Do you have to be really careful about the amount of the product that you're adding in? Is that something you're having to work on?
We're testing it here to see if we have to use exactly the same quantity or more or less. So we don't know it yet, but we are close to finding it out. Life has to be full of richness, excitement. We can't always stay with butter.
That's true.
Yeah.
How does this compare price-wise? You know, you think about buying the ingredients for a muffin and you need to buy your eggs and your butter and flour. Does this make it much more expensive?
So right now it's more expensive, that's why it's not out there yet. So we are constantly improving the process, the methods. Of course, in the future, everything should be affordable. We don't want to make something that nobody can buy. It makes no sense.
Bio is a B2B business, meaning it sells its products to other food providers. It's currently working with bakeries and food factories to get on the market.
So next step is I'm gonna put the dough in the cupcake mold and we're gonna bake the muffins.
Does it affect the cooking time?
No, what we want to do is to keep everything the same, but we want to be perfect, so we keep testing. You can smell it.
Not that strong.
So what do you smell?
I think just the kind of yeasty dough smell. It doesn't smell any different to normal cupcake mixture.
Oh no, and it depends on the quantity. So let's put the muffins to the oven. So we're gonna give there about 10 minutes. Do you wanna look inside?
Yeah, let's have a look.
So let's have a comparison. So we made two. This is a regular muffin, and this is also regular, but with our regular recipe, but with our biomass added. So if I got it, like if I break it, so it's a pinkish.
Which are very pink on the inside, much pinker on the inside than they are on the outside. But actually the consistency looks exactly the same.
So smell both of them.
Okay, so this is the original muffin without your product, using usual ingredients with butter.
Yes.
And it looks and smells like a vanilla cupcake. And tastes delicious. Okay, that's really good. Very sweet.
And
Next.
now the next.
Your product.
Yes.
Okay.
Please give it a try.
So this has your product replacing the butter.
The butter, yes.
And smells lovely and looks really nice. A bit salmon pink in colour. Oh, and tastes delicious.
Is it same or a bit different?
A really strong odour in the powder form has not carried through to the cooking process. Oh, that's delicious. I could quite happily eat all of these now.
IO wants to put out a huge range of products on the market, and that means testing new strains of yeast that can be used to make different things.
So I'm responsible for the strain engineering. We add different DNAs to the genome of our yeast, and then we want different outcomes from it. So we want the yeast to produce different types of fats and oils. So our vision with these different strains is that at the future we will have a library of different strains that are tailor-made for what our clients need.
Have there been any surprises along the way?
Many. I would say our yeast is very unpredictable and hard to engineer. So in order to be robust, it has to have a very robust cell structure and a very robust genome. So that's very good for the bioprocesses. But it also makes our life harder in the genetic engineering part, because the ideal cells for genetic engineering are always the ones we call domesticated, so that they have thinner cell walls, they have less genes in their genome, and that's not the case of our strain. Our strain is very robust, so that's why it makes it so much harder.
So robust that IO scientists had to create their own genetic engineering strategies to insert DNA into the yeast genome and produce different strains.
Here we have the thermocyclers. So basically it's where we run the PCR reactions, and which means is that the DNA will be multiplied in exponential time. So we have a lot of DNA to be able to put that inside the yeast genome. So after we have enough DNA, we take this DNA and the cells, and then we add the DNA, the cells, and some other reagents in the robot, and then the robot will do all the pipetting for us. So it will mix the DNA, the reagents, and the cells, and then we will have the cells with the transformed genome.
All this talk about genetic engineering can make people nervous, and some of those worries are genuine. Some genetically modified crops can be bad for the environment, and others have raised concerns about their effect on people's health. IO says its current products and processes are based on yeast that's not genetically modified, but it is exploring its options for the future.
When you think about the food we eat, hearing it's been genetically engineered might put some people off. What would you say to them about those fears?
So humans have been doing genetic engineering for a long time, but they have been doing that in the dark. Nowadays we know what we're doing, we know what we're putting inside, so we can prove that it's safe and we can track it. So it's actually safer than most of foods we have been eating already.
But there is this perception that genetically engineered food is food that you want to avoid. Talk to me about that perception.
I think it has been a misconception for years, because we were still learning how to work in a genetic modified organism. So some of them maybe weren't doing that properly, but nowadays the technologies are so evolved, so we know exactly what to put inside genetic modified organisms. And not only for yeast, but also for plants, we know how to use them to avoid other things like pesticides, for example. So now it would be best for a human to consume plants that are modified and they are more resistant to whatever harsh environment than using pesticides, because the pesticides are really bad for you. So we know how to tackle that and make the GMOs safer and adding more benefits.
In fact, most of the proteins we eat, whether it comes from plants or animals, are made up of the same 20 or so amino acids. And that doesn't change if the food is genetically modified.
A final question on that. Is the future of food genetically engineered?
For sure, because we have been seeing how the planet is going crazy and the climate is going crazy. So the only answer to that is to make genetic modified foods to withstand both the high temperatures, the floods, and also because we would need to use more land to feed all the people that are in the planet. And that's not possible because we have a limited space. So growing things through fermentation saves that space, because we can do it vertically, right, in tanks. So I strongly believe that all the crops and all the foods we eat will come from genetically modified organisms, either plants or yeasts or other microorganisms.
Back at Fibenol, Raul showed me other products that could be made from sawdust. It's not just food, but other items that are part of our everyday lives.
So remember the lignin, or the glue, what brings the chains together inside the wood. This lignin is actually under our feet on this location, so we can use the lignin to replace the bitumen in asphalt. So this is one very easy to understand application from our products, and we can also do biocomposites from it. So here is example of trash bags, for example, which are made partially from this very powder or this wood glue.
Does that make any difference to the way it feels?
You can feel it's slightly rougher, I would say, but the same quality. So and I would say it smells a bit as well, like a fresh wood, because you have this natural polymer or the lignin.
It does. It's
in here.
kind of like a sauna smell.
Yeah, exactly. So every time you you take your trash out, you can get a little sauna vibe as well. So
I mean, you could smell of rubbish bags made of wood.
exactly.
The bags are also biodegradable. The sawdust can also be used to make insulation, the kind that goes into the walls of your house. But most of these products need to be properly certified before they go on the market. For the people of Io, getting food safety certificates from the European Union could take up to 10 years. I even had to sign a consent form to taste the muffins you saw earlier, because the oil used to make them hasn't been certified yet. And Io is competing with a huge industry. Nearly 80 million tonnes of palm oil was produced in 2023, and the sector's projected to have a market value of more than $98 billion by 2030. But Namaila is confident they can still make a difference.
Just by calculations done just with the process currently as it is, which is not like a very big scale, we know that we can use, for the same amount of fats and oils, we would use 10 times less land to produce, at least 10 times less time for the production, and way less CO2 production, at least 10 times less if you compare with animal fat production.
Overall, Io says its products could cut 160,000 tonnes of CO2 emissions a year that would otherwise be released by the palm oil industry. That might seem like a drop in the ocean, with global carbon emissions reaching approximately 40 billion tonnes in 2023. But the solution to climate change will never come from just one thing. It depends on a myriad of innovations like this. Io is aiming to build a proper production plant and license its technology to other companies. It's also experimenting with other types of industrial waste.
We currently also have been working with residues from dairy industry, juice, pomaces, tea production, and other types of beverage productions. I guess my biggest dream is like to actually mitigate quite a lot of CO2 and damage to the plant. So hopefully we get there.